Ever since the explosion of the first nuclear bomb over Hiroshima and Nagasaki in 1945 in Japan, there has been spectacular evidence that the tremendous store of energy contained within the nucleus of certain unstable atoms can at last be released.
Little by little, during the succeeding years, the veil of secrecy has been lifted until finally, as a result of the UN International Conference on the Peaceful Uses of Atomic Energy held in Geneva during August 1955, virtually complete information of the possible uses of the energy from the fissioning of the uranium has now been made public.
The basic element of nuclear energy producing is uranium, which was discovered in 1789 by German chemist Martin Keppert.
After that, a lot of basic features and regularities opened by scientists like Einstein, Meitner, Frisch, Bohr, but the harnessing nuclear fission developed only for army in early 1930s.
The first nuclear weapon reactor was only the beginning, and most research focused on developing an effective weapon, especially for use in the Second World War. Only after war, scientists tried to cooperate and found new association called AEC, Atomic Energy Commission, in 1946. 2 years later, AEC announced the possibility of peaceful usage. Of 1949, scientists announced the selection of site in Idaho, United States, for the National Reactor Testing Station. It is considered that the first electric power produced by atomic station was in 20th of December 1951.
Advantages: uranium, the most common fuel for nuclear power plants, cheap and widespread all across the world. Also, utilized uranium can be reused later after their regeneration, that give a belief what in the future nuclear facility can be non-waste.
Nuclear power plants don't need a frequently maintenance.
Nuclear reactor can keep working without oxygen. That means manufacture can be moved in the space, underwater or underground.
Using of nuclear energy is safe for environment because it doesn't produce carbon dioxide like at thermal power plants.
Disadvantages:
The extraction and enrichment of uranium can expose employed personnel by radioactive dust and also lead to the release of this dust into the air or water.
the waste of nuclear reactors remains radioactive for many years. Existing methods of their utilization are associated with technical, environmental, and political problems.
Despite the fact that the risk of diversion in nuclear power plants is small, its potential consequences, the release of radioactive materials into the environment, are very serious.
The official nuclear materials in the wrong hands can provoke nuclear terrorism or black
Nowadays,
Currently, in more than 30 countries around the world, 420 nuclear reactors, with a total capacity of about 350,000 megawatts. There are 130 reactors during the construction phase in different countries with a total capacity of over 150,000 megawatts.
In 2011, the nuclear power plant produced 12% of global electricity. The share of nuclear power plants in the total electricity production in various regions is very different. In 2011, the greatest amount of electricity was generated in nuclear power plants in Western Europe, 25%.
The least is in the Middle East and South Asia 1%, and in Southeast Asia and the Pacific 0%. On a global scale, the diversity of nuclear power plants in electricity production declined from 16% in 2002 to 12% in 2011.
In its central part, the reactor core's heat is generated by controlled nuclear fission.
With this heat, a coolant is heated as it is pumped through the reactor and thereby removes the energy from the reactor.
Heat from nuclear fission is used to raise steam. which runs through turbines, which in turn powers the electrical generations.
Nuclear reactors usually rely on uranium to fuel the chain reactions.
Uranium is a very heavy metal that is abundant on Earth and is found in seawater, as well as most rocks. Different isotopes also have different half-lives. U-238 has a longer half-life than U-235, so it takes longer to decay over time. This also means that U-238 is less radioactive than U-235. Since nuclear fission creates radioactivity, the reactor core is surrounded by a protective shield.
This containment absorbs radiation and prevents radioactive material from being released into the environment. In addition, many reactors are equipped with a dome of concrete to protect the reactor against both internal casualties and external impacts.
Atomic energy, like any other kind of energy, with significant advantages, also has serious fundamental drawbacks.
However, very soon we will witness a new era in the development of nuclear energy. Only the future will show how safe the use of the atom in the world's purposes.